subtraction, notice our first objective is still the same. We're going to force the denominators to match. You have to be able to force that to happen, and then you're subtracting now the numerators instead of adding them together. So this slide, by the way, it's pretty much the exact same slide that we saw with addition. It's just instead of addition, it says subtracting. And instead of addition right here, it's showing subtraction. So if we need to force the denominators to match, that's great. Again, this is just telling us that the sizes of the pieces are the same. And then we can start the subtraction on that. Of course, we'll always simplify in the end. Again, the point here as well, just like we did with addition, is you do not need lowest common denominators in order to subtract. You just need common denominators to subtract, even though in the assignment they may say, well, what would be the lowest common denominator? All right, and that's fine. We know how to do that. It doesn't matter if it's addition or subtraction to find the lowest common denominator. It's just the lowest common multiple, but now it's with fractions. Okay, so let's look at our thirds right there. Let's make that a little bigger. How many thirds do we want? All right, so let's take 7/3 and subtract 6/3. So just because we're pretty much copying the same process with addition, the denominators here already match in thirds, so I know that's the size pieces I'm dealing with in thirds. But then I'm going to subtract the two numerators of 7 and 6, which 7 minus 6 is 1. 1/3. Now, we should check, can that be simplified 1/3? No, it cannot, so that one's done. I'm going to emphasize this here. This one came already with common denominators, thirds. If they didn't match, then we would have had some work over here that we would have had to do in order to force those denominators to match. But these ones match, so we're in good shape. All right, so I'm going to do this mathematically, and then I'm going to model it just like we did with the addition stuff. Okay? So the denominators match already in fourths. We are using subtraction. We start with the 9/4, and then we're going to subtract 5 of the fourths. So the answer, the sizes of the pieces is going to be the same fourths, but 9 minus 5 is going to be 4. Now that would read 4 divided by 4, by the way. Anything divided by itself is 1. Okay? So in the beginning, you had 9 pieces that were fourth size pieces. So I'm going to do it like this. I'll use rectangles here, or squares, I guess. So 9/4, we got this one. Let's kind of set this up here. There we go. All right, so I'm going to set this up. I'm going to give myself 9 of these fourths. So I know it's not pizza anymore, but hopefully that's okay. So I have 9 of these fourths like this. There's 4. Another one is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we need a 9th one right there, okay? So what I have shaded represents 9, and they're fourth size pieces. Now, minus 5 means that we're going to, again, I'm still thinking about pizza, so I'd say we're going to eat 5 pieces. These are rectangular, so maybe brownies would be more appropriate. But, okay, so we're going to eat 5, right? So this piece, boom, we're going to eat this one right there. There's 1, 2, 3, 4, 5, right? So I'll even show that right there. We ate 1, 2, 3, 4, 5 pieces. So what are we left with? Well, now we're left with this full piece. There's 4 of the fourths, which really is just 1 full piece. Or 1 full bar, I guess. 1 full pan of brownie, whatever you want to compare it with. But 1 should be our final answer there. Okay, so 6/7 minus 3/7. I'm not going to model this one, but I'm going to show mathematically what we would do. Now again, the purpose here is that the denominators are the same, so we're going to skip some of that process. But since the pieces are the same sizes, the sevenths, we'll just keep the sizes the same, sevenths, all right? You wouldn't do 7 minus 7, then you'd have nothings, which is weird. But then we have 6 pieces of the sevenths minus 3 pieces of the sevenths. Again, it's like you have 6 pieces, then you're going to eat 3 of them. So if that were the case, you'd have 7th size pieces, but you'd have 3 left over. Okay, this green 3 is different than the purple one. And that can't be simplified, so that is done. So that's what this slide is for. If the denominators don't match, we will have to force them to match. All right, but we have a method to do that. We have 3 methods to do it. 2 of the methods will automatically give you a lowest common denominator. But the method that I tend to use will not always produce a lowest common denominator. But what it will do is it give us a quick common denominator, and that's all we really need. Denominators, we saw this with the addition stuff as well. It's the same exact slide, by the way. It's really just for the video, but yeah, we got to find a common multiple of the denominators. So if you just multiply the two denominators together, like we saw with the addition stuff, then it will automatically produce a common multiple for the denominators. And then you'll scale the fractions accordingly, which means we already know what we need to multiply stuff by. We don't have to keep track of which multiple it is, or use the prime factorization for that stuff. Then we subtract in this case. The last lesson was add, and then in the end, if we can't simplify, then we'll have to go through our divisibility rules to see if stuff can be simplified, okay? So it is important to remember your divisibility rules because it's going to help you with the simplifications. Okay, so we have 7/8 minus 9/12. So I'm going to do this mathematically, and then I'm going to model it. And then if you don't like the modeling, just ignore it, okay? Because some students are like, Mr. Sal, I just like this, I just like the math part of this. I don't like the modeling. Okay, don't worry about the modeling. You don't have to model it. Okay, so I'm expecting two new fractions with subtraction between, but I can force these denominators to match right away. Is it going to give me the lowest common denominator? It will not. So in my heart, though, I really want to because it's going to be a much lower, whatever. I'm going to show that it still works. Maybe I'll do it like 3 times. I don't know. Okay, so I'm going to take the 8 denominator. I'm going to multiply it into the second fraction, both denominator and numerator. Now our second denominator, I should say, 8 times 12 is going to give us 96 there. And then in the numerator, 8 times 9, 72. Okay, now again, we're forcing the denominators to match. So without showing the math, I'm expecting this denominator, our first denominator, to be 96. But how did we get that 96? Well, we take the second denominator, which is 12, and then we multiply it into the first denominator, which is 8. So it automatically forces the denominators to match because it's 8 times 12 and 8 times 12. So it'll be 96, but I still got to do 7 times 12 as well. So 7 times 12 is going to be 84, looks like. Okay, now that we have the denominators matching, just like we saw in those last problems, they're the 96th size pieces, but I can just subtract the two numerators. So I've got 84 minus 72. I'll have to stack and subtract that, just in case we can't do that in our head. So 84 minus the 72. Minus 72, I'll do it in green. Okay, 4 minus 2 is 2, 7 minus 8 is 1. Okay, that wasn't too bad. Now this is still in 96ths, which is, we're going to 12 96ths. Can that be simplified? Yes, it can. So we do need to do some simplification. Now, if you had your multiplication tables down, you would know that 96 is divisible by 12, just like 12 is. I'm going to assume that you didn't notice that. Okay, so I'm gonna do the simplification here, but I'm not going to show the division. So if you saw that they're both at least divisible by 2, that's a great start. And you could have said, well, I could take 12 divided by 2 and 96 divided by 2. That would have given us 6. And 48, looks like. Okay, and then you'd say, well, that's divisible by 2 as well. So you'd say, okay, divide this by 2 and this by 2 as well. Again, I'm going to skip the math there, the long division. But I know 6 divided by 2 is 3, and 48 divided by 2 would be 24. Okay, sorry, my writing's getting smaller, trying to save space there. That made it much smaller. Anyways, this new fraction, 3 and 24 are both divisible by 3 now. So I'm going to divide them both by 3. 3 divided by 3 is 1, and 24 divided by 3 is 8. And that is as simplified as I can make this, okay? Now let's see, if you had used the lowest common denominator, you probably would have gotten this, 3/24, because you could have said, well, 8 times 3 is 24, and 12 times 2 is 24. Yeah, the math becomes a little bit easier, but Not everyone would know that. It takes some experience to know that 24 is your lowest common denominator. It takes experience with not just the math, but also with memorizing your multiplication tables, because 8 and 12 are within those bounds, those boundaries. So let me model this, because you're going to see this kind of stuff on the assignment too. Okay? So 7/8, and I got to use rectangles on these. So my first fraction, 7/8. Need 2 of these though. Okay, first up, I've got 7/8. So I need 8 pieces in this first one. I'm going to call this a pan of brownies because I'm using a rectangle there. See if I can do this decently. That's not great, but it'll work. And we got 7 of those. Okay, so 7 of these. Oh, maybe I did this. May have done this slightly poorly, but the second fraction was 9/12, right? So we got, first up, I'm going to need to split this into 12th size pieces. So I need 11 lines there. All right, here's my second one. That should be, let me just count those to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's not great, but it'll work. And we need 9 of those shaded in. Okay, so let's do 9 of them. And then my top one, this is where it's maybe kind of important to stay in the lines. There we go, that should be 9 right there, okay? Now, at this point, I'm modeling this, right? And some students are like, well, why did you cut this one vertically and then this one horizontally? It's because they're not the same size pieces. So, what I'm gonna do is I'm gonna take each cut and then transpose it onto the other one. So this first one is 7/8, this next one is 9/12. But these cuts I'm going to put on top of these ones over here, and then I'm going to take these cuts and make these cuts over here. What that's going to do is, by making the same cuts on both of these, it's like doing what we did up here. Okay, it's going to make the sizes of the pieces 96ths. So let's do that here. Let's see if we can take the red ones first, because those are easier. So I got 1, 2, 3, 4, 5, 6, 7. And because I'm a math nerd, I'll clean that up a little bit. Okay, now if you were to count these boxes, which you could do, I'm not going to, but this would be 96 total pieces of brownies, right? So they're size 96ths. But I've got to do the same thing with this other one. Okay, that worked out pretty good. Now again, the second one, or the first one rather, again, if you were to count all the pieces here, there would be 96. So what did we do? We changed the sizes of both pans of brownies to be 96ths. Okay, well, how many pieces are there then? Well, in the red, that would have been, well, 7 times 12, which would have been 84, just like we found above. And then the purple stuff, that would have been 9 times 8, which is 72, 96. Now, since we are subtracting these, each one of these purple ones will zero out one of these. So we'd have to take out 72 of them, which would then leave us with, what do we get, 12? Yeah. So pretty much, ooh, this is where it becomes really good if you can draw these goodly. But these 12, I'm going to say these 12, we got rid of these 12, these other 72 right there, okay? You can count them, but it's a lot more work than I want to do right now. But we're left with these 12 pieces, so that's why we end up with 12 96ths. We've already done the work to get down to make this. It's really, this piece right here would be 1 out of 8 pieces if you were to make it, these pieces a little bit bigger. That's the modeling. And yeah, being in this, using 96, maybe that's, you know, some students are like, that really sucked. Well, it wasn't great, but I hope it hits the point. That's all we really need to know is, why is this working? It's because really, if you look at like brownies or pizza, it still works. So, as usual, with 3 values, I'm going to only focus on 2 at a time, starting from left to right. So I've got 13 14. Let me start that over. 13 fourths minus 3 fifths. And yeah, I need common denominators here. Let me take this down so we can work with just this part. So I'm going to take the 4 denominator and multiply it by the 5 denominator and numerator with the same fraction. So this should provide 2 fractions, which are subtracted. The second fraction there, 5 times 4 in the denominator would be 20. In the numerator, 3 times 4 is 12. And we take the 5 denominator and multiply it into the first fraction, denominator and numerator. So again, this will guarantee a common denominator of 12. In the numerator, we have 5 times 13. So I'm doing the work here for 5 times 3 is 15, carry the 1. 5 times 1 is 5, but adding the 1 makes that 6. So 65 twentieths minus 12 twentieths. Now that we have the denominators matching in twentieths, we'll just subtract the numerators of 65 and 12. So this will give us some number of twentieths. Now if this can be simplified, which I don't think it will, but if it could be simplified, then we would. I now have 65 minus 12. So 5 minus 2 would be 3 in the ones place value, and the 10, 6 minus 1 would be 5. So 53 twentieths. And that is from just the 13 fourths minus the 3 fifths. So we did this part right here, and we get 53 twentieths. Now we need that second fraction, the last fraction there, minus 3 sixths. Now if you notice that 3 sixths could be simplified, you could do that. But I'm going to assume that you didn't notice, and so we'll just continue as is. I'd have 6 times 20 in that second denominator. This is going to give us 2 new fractions. Same value though. And I'll multiply the numerator as well. So multiplying by 20 is not too bad. 6 times 2 would be 12, and then tack the 0 on. And in the numerator, 3 times 2 is 6, but tack the 0 on. So 61 twentieths. And then in the first fraction, we'll take the 20 and multiply it by the second denominator, 6, but 53 also by 6. So again, we've guaranteed common denominators of 120, but 6 times 53, we'll have to do the work up here. So 6 times 3 is going to be 18, carry the 1. 6 times 5 is 30, but add the 1 would be 31. So 318 1/20ths minus 61 twentieths. So in 1/20ths, what is this? We got 318 minus 60. So let's take that 318 and let's subtract a 60. I should have given myself more space, but 8 minus 0 is going to be 8. And then 31 minus 6 would be 25. So 258 1/20ths. Can't even copy stuff down right now. 258 1/20ths. There we go. Okay, this can definitely be simplified because of the 8 and the 0. Is it, looks like it, assume it's divisible by 4. Can't tell for sure though, so I'm just going to divide by 2. Now again, I'm going to skip the long division here.
43 twentieths.
So we should end up with that answer, but I'll skip this division right here, just in case, you know, we know it's at least divisible by 2, right? So let's see, 1/29er, and then this one would be a 60. Okay. Oh, okay, now they're divisible by 3, so we'll have to do that as well. Okay, so there's our 20ths, and 129 divided by 3 should be 43. So it appears that we've done it. Now, the last thing I'm going to mention about this problem, just because we finished Unit 2A, Module 2A, which was multiplication and division. Remember, the common denominator thing is only for addition and subtraction, only. You do not need common denominators for multiplication and division, right? It's big numbers. Now the process is going to still be the same. In order for us to subtract these, we need common denominators, right? Boom, let's start with that. So 73 over 1, right? Now, yeah,
Keep it normal.
yeah, that's what we'll do. So since my denominator here is 1, it's easily made into a 420. So I can just take that and multiply it by 420. But here's where the work comes in. If I multiply by the denominator, and multiply by the numerator as well, yeah. Well, that will give us a new fraction with a denominator of 420, just like the second fraction had a denominator of, well, 420. So the denominators will match, right? But I've got to do some work right here. So let's get to work. We have 420 times 73. Now, if you wanted to, you could just do 42 times 73 and tack a 0 on at the end. Again, I'm going to proceed like we don't remember that rule, although if you did, it may make this a little easier. I don't know. Okay, so in the ones place value, 3 times 0 is 0, 3 times 2 is 6, 4 times 3 is 12. So 3 times 420 would be 1,260. Now we're in the tens place value, so I have this first 0 for the ones, because you can't have ones when multiplying by tens. 7 times 0 then is 0. 7 times 2 is 14. Carry the 1. 7 times 4 is 28, but add the 1 makes that 29. Now I will add these together, and this will give me my new numerator. All right, so 0 plus 0 in the ones, 6 plus 0 in the tens, 4 plus 2 in the hundreds, 1 plus 9 in the thousands, carry the 1. 1 plus 2 in the 10,000s, 3. Well, that's a lot of 420ths, but it is doable. So we now have 420ths, and we're going to subtract 27 from 30,660. All right, so in 420ths, let's see what this is. We got 30,660, and we're going to subtract the 27 there. So I have to borrow. I got 10 minus the 7 then, which is 3. 5 minus 2 is 3 as well. Drop the 6, drop the 0, drop the 3. All right, 30,633. Well, they're not both divisible by 2, but, and this may not be so obvious, both of them are divisible by 3. 420 is pretty easy. 4 plus 2 is 6. That's divisible by 3. But this one, divisible by 3. 3 plus 0 is 3, plus 6 is 9, plus 3 is 12, plus 3 is 15. So we are going to simplify this by 3. We're going to divide by 3. Now I can do 420 divided by 3. That'd be 140. Yeah, I had to double check that. But I don't know what we could do it, but 30,633. I'm going to use long division on this one just because it's so fun. Okay, so here comes my long division. 3 goes into 3 once. Subtract 3 there. That zeroes out. The 0 right there, it won't go into the 0. So I gotta put a 0 there to hold that place value as well. And then I'll drop the next place value, the 6. I don't really need the 0, but 3 goes into 6 2 times. 2 times 3 is 6, so that removes that. We'll drop the next 3. 3 goes into 3 once. 1 times 3 is 3. So we'll drop the last 3. 3 goes into 3 once. So that'll give us a remainder of 0. But that quotient there is my new numerator, 10,211. All right. Well, 140 is not divisible by 3. Well, neither is 10,211. Both of them are not divisible by 2, 10, or 5. 140 would be divisible by 7, though. Yeesh. So yeah, just checking some of the odd ones, like 7. I know 140 is divisible by 7, but yeah, the 10,211 shouldn't be, so that should be completely simplified right there. That is subtracting fractions. Again, if we need to, we will force the denominators to match. On all the homework problems, you will not need to, though. Some of them will come with matching denominators. Then you just gotta be able to subtract. Maybe part of the objective which we could add is make sure that you're able to simplify the fractions as well, which goes back to our divisibility rules. But we'll have to do it one way or the other.